So in the last video, we talked about the SSH protocol, and that's how you can kind of authenticate with a virtual machine or a VPS. And I really only covered one aspect of that, right? I covered the aspect of how does the machine actually verify or authenticate the user who's making the request. In this video, I want to kind of take a step back and talk about the initial connection and how the handshake kind of works without going into too much of the nitty-gritty details about it, because it can kind of get a little bit complicated. So we're going to talk about, as a user, let's say you want to SSH into a machine, right? What is the first thing that kind of happens with this protocol? So you are going to make a request to a machine, and that machine is going to have a public key on it. I'll just call it the host public key. And then also it's going to have a host private key. Okay, so these are kind of, they exist on the machine when it's created. It's not the ones that you would be adding into the machine manually. They just kind of exist, right? Now, when you make this initial request to the machine, I do want to kind of state that your own machine is going to first create a client private key and then a client public key. So I'm going to just copy these over, client public key. Here we go. But with one little caveat, there is a process that kind of happens during this connection, right? There's something called an ECDH protocol, where technically both of these keys are basically ephemeral. So every time you connect to this machine, you do have to kind of set up a new set of keys. And what happens is we are going to send over this public key to the VPS. So step one is send over ECDH public key. And I'll say client public key. And by the way, correct me in the comments if there's anything I misexplained. That I've kind of spent some time trying to research this, make sure I can say it right. So I'm probably going to screw up anyway. So this gets sent over to the VPS, right? And it is going to basically get stored inside the VPS so it knows how to potentially communicate with this user. Okay. Now, when this happens, the VPS also has to create an ephemeral server public key. I'm just going to say ephemeral server ECDH public key. Okay. And then technically there's also a private key, which is going to be created from this too. So I'll just go ahead and put the private key over here as well. We can say private key. And I'll explain the keys in just a second. Like, it all kind of makes sense in just a second, so bear with me. So the server is going to basically send back the public key, the ECDH public key, in addition to some other things. So it's also going to send back a signature, and that signature is going to be generated by this host private key over here. So it uses the private key to generate the signature, but then it also is going to send back the host public key as well. So these three things basically get sent in like a response. The signature is going to basically be the thing that verifies that these things are accurate and not tampered with, and they get sent over. So from the server, they get sent back over to the client. So I'll just go ahead and make a little back arrow here. I'll say send back server ECDH public key and host public key. All right. You guys confused yet? Because I am kind of confused. Now, step 3 is the part that might be kind of familiar with you. So if you've ever tried to SSH into a machine for the first time, if your machine has not connected to it, you may see a particular message. Okay. And that message looks a little bit like this. Okay. Basically telling you that, hey, you're connecting to a machine and it's sending you back a key print, a fingerprint of what the keys kind of look like. And it's up to you to say yes, no, do you confirm this? Okay. So when you press yes for the very first time you try to connect to this VPS, your computer doesn't know about it. And when you confirm it, what happens is that's going to put basically this fingerprint inside a file called known hosts. And this known hosts file basically has a giant list of host names and the public keys, or at least the fingerprints of those public keys, so that in the future, if you connect for a second time or more times, it can look up this key and compare it against that key that was sent back in the second process. Because if they change, you know that there might be something that's wrong, right? The keys might have changed the machine, or there could be some man in the middle who is trying to send you back a different key. And it wants to warn you and not let you just automatically connect and do the whole process, because there could be, a potential issue that you want to address, okay? So that's the first step of kind of this authentication process, is we store that public key, that host public key from the server inside the known hosts. Now, if you remember, we got sent back these three things, right? We got the ECDH public key, we got the host public key, and we got the signature. We have to first verify that the data that was sent back in that response is it actually coming from the machine that we're trying to connect to? Because the signature was created with the private key. And so what we need to do is take that host public key and verify this signature to make sure, hey, this is actually signed by the private key that should only live on that VPS, right? So if it is verified, then what we do is we compute a shared secret. So I'll say shared secret. So the way this shared secret, I'm gonna go ahead and just put a key lock here, is computed is basically it takes the private ephemeral key that we created on the client, and it combines that with this other key that was sent in. So basically there's some cryptography, some math that's going on where you can create a shared secret on the client by using these keys. And then also the server is going to be doing the exact same thing. So it needs to go and compute its own shared secret, but it's going to be using something else. It's going to be using the public key that was sent in from the client. So I'll just go ahead and like move this one down here, plus the private key that was generated on the server, okay? So now that we have a shared secret key and a shared secret key over here, we are able to actually start sending encrypted messages. So over here, I can actually do step 3, and we can actually start sending encrypted messages, which the message is gonna be encrypted using, you know, in this case on the client, it's gonna be the client's public key. All right, at this point, this graph is getting very, very confusing. So I went ahead and put locks next to the private keys so I can like easily identify them. But the point I was trying to make is that when we send over that encrypted message, we're going to be using the client's public key to encrypt the message. And then when it gets to the server can use that shared secret to basically decrypt it. So that's basically the algorithm. Honestly, at this point, leave a comment below if I did a poor job to explain this. I'm trying to get better at making these diagrams. I was going all in on making AI videos, and I kind of lost touch with doing these diagramming videos. So I'm kind of rusty, but hopefully I can get better at it and I can make it a little clear to people who are watching, who want to kind of learn different things. Anyway, hope you guys enjoyed. Have a good day and happy coding.